Okay, let's give you guys some more practice. So determine if this alternating series will converge or if it will diverge. So press pause and have a go. Okay, so to do this, we're going to use the alternating series test. So when it comes to the alternating series test, it says that you have to discard this alternating -1 + 1, -1 + 1. It's saying you should discard this and then extract the UN and then extract the UN. So that will then give you this thing here. And then make sure all the UNs are positive. So this thing here, well, you can visualize it like this. Hang on, over 1. So you can visualize it like this. So n is moving from 1 to infinity. So this will always be positive. And then you're adding another thing that will always be positive. That means the denominator will always be positive. 1 divided by something, that's always be positive. Well, the whole thing will always be positive. So condition 1 has been met. And then check number 3. So number 3, make sure that the UN heads towards 0. Make sure that the limit of this heads towards 0. So if you visualize this as this 1 over this thing here, you can see that the denominator, as n heads towards infinity, you can see that the denominator will just get bigger and bigger and bigger and bigger. So 1 divided by something that keeps on getting bigger and bigger and bigger means that the limit of this thing does the limit will head towards 0. So condition 3 has been met. So now we need to check number 2. Make sure that it's non-increasing. So looking at our UN, to check number 2, we would map a continuous function on top of this. So map a function on top of that, and then look and then differentiate the function, and then look at the gradient. If the gradient's negative, if the gradient's always negative, then you can say that the original function will always be going downhill. Basically, it's not increasing. The next term must be less than or equal to the current term. So if the gradient, so this is our function. If you differentiate it and then the gradient's always negative, it means that the function itself must be going downhill. So if it's going downhill, then it's non-increasing. Okay, so where were we? We were here. We would map a function on top of our UN, and then we would need to differentiate it. So differentiate this. The power that would come down here, and then this stays intact, and then this gets minus by 1. That will then give you this, and then times the derivative of the bubble itself. So that would then be this, and then from here you can actually tell that it's always going downhill, because remember, n is moving from 1 to infinity. So this will always be positive. This will always be positive, this whole thing here will always be positive. So let's just remove this from our mind, and then when you look at this, let's just concentrate on this. Remember, this part is always positive. Because of this -2, visualize it like this. Hang on, root n plus root n plus 1, and then you've got this negative here. Let's leave it this here. So remember, n is moving from 1 to infinity. So this will always be positive. This will always be positive. The whole thing here will always be positive. But because you've got this negative here, it makes this block here always negative. This block here will always be negative. This will always be positive. So that means the derivative is always negative. If the derivative is always negative, then the original function itself must always be going downhill. So condition 2 has been met. Because it is always non-increasing. So 1 has been met, 3 has been met, now 2 has been met. So therefore we can conclude that our series will converge. So therefore we can conclude that our series will converge. Okay.